Hello! Our lesson today is an introduction to polynomials. Our goal will be to work on defining the parts of a polynomial, and also to be able to learn how to combine like terms and also add and subtract polynomials together. So that's our goal. Let's get started. We're going to start with definitions here. Before we do anything, we should probably define what a monomial is. A monomial is any number, variable, or any combo of a number and a variable. For example, the number 3, that's considered a monomial. A variable, if we just had x, that's a monomial. We could have a bigger number, 100. We could have a bigger x, x to the 5th. These are all monomials. We can even have when they're both together, like 5x squared. That is also a monomial, or 3y to the 5th. Usually the rule for monomials are that the power has to be positive, so the exponent has to be a positive sign. If we were to say that this is -5, that's not usually what we call a monomial. Okay, good. Let's go ahead and move on. So a polynomial then, poly meaning multiple, is just when we put more monomials together. So for example, x plus 7. X plus 7. Whenever we have two or more monomials put together with either a plus or a minus sign, that becomes a polynomial. We could have x to the 5th plus 2x squared minus 11. That is a polynomial. Or 4y plus 13, or 17x squared minus 5x plus 11. These are all polynomials. Okay, so the name terms basically just represents the actual monomial. So terms are the monomials in a polynomial. So if I had x cubed plus 3x squared plus 2x plus 5, this has 4 terms. This is the first term, this is the second term, this is the third term, and this is the fourth term. If I had 4y minus 11, this has 2 terms. This is the first term, this is the second term. We usually like to write polynomials in ascending order, meaning that the terms with the highest power come first. If we had like 5 minus 3x plus 2x squared, that is not ascending order. We usually like to write the highest powers first, so this would come first. This would come second because the power is 1, and then this has no power. So do realize that we usually write polynomials in what is called ascending order, going from or descending order, going from greatest to least. Okay, the coefficient. The coefficient is the number of each term. So if I had like 3x squared plus 6x minus 11, this is the first term, and we would call the coefficient of that term, the coefficient is the number. So in this situation, 3 is the coefficient. What's the coefficient of this term? You bet. You should have said 6. 6 is the coefficient. And this is the third term. What's the coefficient of it? Yep. You got it, -11. So remember, coefficients can be negative. So if I had like -2x squared minus 7x plus 11, the coefficient of this is -2, the coefficient of this is -7, and the coefficient of this last term is 11. We usually do define another coefficient. We call the leading coefficient. We do have a leading coefficient, and that is the very first number that appears when it's written in order. So when it goes from greatest to least, so when it's in ascending order, the first number with the first term is the leading coefficient. In this situation, 3 is the leading coefficient. And here, -2 is the leading coefficient. Ooh, what would be the leading coefficient of this one? That always kind of tricks people up. Remember, the leading coefficient is the number that goes with the very first term when written in descending order. So the leading coefficient of this polynomial is actually 2 because it's not written in order. Remember, highest powers go first. The leading coefficient of this polynomial would be 1. There's an implied 1 right there. Okay, good. Last thing we want to talk about is the degree. The degree of the term is just the exponent. It's just the exponent. So if I had, for example, 5x to the 7th plus 2x to the 3rd plus x minus 15, we could find the degree of each term. So this is the first term, and the degree would be 7. It's just the highest power. This, here we have the degree of 3, the power associated with that degree. For this term, the degree is 1. And for this last term, the degree is 0 because there are no variables. There are no variables that are associated with the last term. Again, just like we do with coefficients, we have a leading coefficient, and we have basically what's called a leading degree. The leading degree, in other words, that's the degree of the entire polynomial, and that will always be the one that comes first, again, when it's written in order from highest to lowest exponents. And so the leading degree for this polynomial is 7, the degree of the polynomial, because that's the highest degree that exists. Okay, well, we've done some work defining some polynomials. Let's go ahead and write up some example questions that you can do in your video notebook, just to make sure you understand all of the lingo that is associated with polynomials. Okay, so here are 4 questions we'd like you to try. You can go ahead and pause your video notebook, pause the video, and use your video notebook to write your answers down. Make sure that you can identify or understand the definitions here. We want to make sure you understand the words like polynomial and term and leading coefficient and degree. When you're ready to check your answer, go ahead and press play, and we'll go over these. Okay, let's see how you did. We've got this first question says, write the polynomial in descending order. That means highest powers come first. So this has the highest power. So we're going to write 5x to the 9th. The next highest power would be this, so plus 3x squared. The next term with the highest power would be this, plus x, and then last would be plus 3. This is called descending order. It's got 4 terms, and we went from the highest power down. Okay, good. Question number 2, identify the leading coefficient and the degree. So the leading coefficient is the number in the very first term when they're put in order. So we should check to make sure these are in order. 3, 2, 1, 0. Okay, good. So we're all right. This is in order. So the leading coefficient, I'll call it the LC, equals 7. And the degree of this polynomial will be the highest power, which in this case would be 3. So it is a degree 3 polynomial. Okay, good. On this question here, it says, how many terms does a polynomial have? This has 1, 2, 3, 4, 5 terms. It has 5 terms. And just to let you know, sometimes we do name polynomials by how many terms they have. For example, monomial. If it was just 5x, that is a monomial. If it's 5x plus 1, that is a binomial. If it is 5x squared plus x minus 3, this has 3 terms, so it's called a trinomial. So based on the number of terms, this has 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. Anything above that, we just call it a polynomial. So this one here, 5 terms, that's just a poly. We don't have special names after anything above trinomial. Okay, good. Question number 4. Identify the leading coefficient and degree. Now, this one's a little tricky because it's got to be in order. So when I look at this, I've got power 3, power 4. That's not in order. So the first thing I'm going to do is write this in descending order. 4x to the 4th plus 2x cubed minus x squared plus 2x plus 9. That is now in order. 4, 3, 2, 1, 0. Okay, good. So now we can identify the leading coefficient. The leading coefficient is always the number associated with the highest powered term. So the leading coefficient, the LC, is negative 4. And the degree of this polynomial is the highest power, which is 4. Okay, great. So that's the first part of polynomials. The next thing we need to do is make sure we know how to add polynomials, which is actually pretty easy because it's all about just collecting like terms. Let's go ahead and take a look. So this part of the lesson should not be anything new. We know already about like terms. For example, if I have 5x plus 3x, well, that comes out to be 8x. We know that we can combine x's with x's, or I can combine smileys with smileys. Get 8 smileys. And we can combine winky men with 3 winky men. So 2 winky plus 3 winky is 5 winky. We know this. We know this is the rule. However, sometimes we fall apart because sometimes there's things in math that are wearing hats. Oh gosh, hats. Now listen, hats are nothing to be scared of. If I've got 5 guys wearing a top hat, looks like Abe Lincoln, plus 2 guys wearing a top hat, what do we get? You know, 7 guys wearing a top hat. Hats do not change anything, okay? Hats do not change anything. For example, what if I had this? 3 guys wearing, this guy's wearing a ball cap. Doesn't really look like a ball cap. Plus 7 guys wearing a top hat. What do we get? We can't do it. Remember, they've got to be the exact same. They've got to wear the exact same hats, or you can not combine them. Okay, they've got to be exactly the same. Now, in math, hats are usually exponents. Okay, if I've got 5x squared plus 2x squared, notice the x's. They're wearing hats. And are these hats the same? You bet. So therefore, we can combine the like terms. We get 7x squared. The hats don't change. Sometimes people are like, oh, I've got 2 hats, and so they're going to put 2 hats, or they do something weird. I don't know. But if you've got like variables that are wearing the same hats and you add them together, it's the same. 3 apples plus 2 apples. Apples are the same, so we get 5 apples. Again, when we combine like terms, things you can add and subtract things as long as they are exactly the same. Okay, so can I combine 3x squared plus 5x cubed? No! They're wearing different hats. You cannot combine those. So just remember, when we're doing polynomials, when we're combining like terms, you're going to add the things that are exactly the like. And if they're not alike, then you just leave it the way it is. Let's take a look at an example. So here's an example of adding 2 polynomials together. Here's our first polynomial. It has 4 terms. 1, 2, 3, 4. Here's our second polynomial with 3 terms. Okay. Again, when you add polynomials, all you simply have to do is combine the like terms. So I'm going to combine all my like terms. Remember, like terms have to have same hats. So here I have 3x cubed, and here's 4x cubed. They have the same hats, so we can combine them. 3 of these guys plus 4 of those guys comes out to be 7 of those guys. Okay? 5x squared. 5x squareds have to be combined with another x squared. Ooh, over here there's no x squared. So there's nothing to add to it. So we're just going to write it here. It's 5x squared. It doesn't change at all. Here we have 1x plus 2x. 1x plus 2x is 3x. And then combine our numbers. We get 3 minus 5, which is 2. So our final answer there is 7x cubed plus 5x squared plus 3x. That's how we add polynomials together. Just combine the like terms. Let's give you guys some practice problems. Take out your video notebook and give these a try. Okay, here are 3 problems we'd like you to do. We're just adding polynomials, so you just combine the like terms. Go ahead and pause the video, try these 3 questions in your video notebook, and then push the play button to see how you did. Okay, let's take a look. We've got to combine the like terms. That's our goal here. So I've got 3x to the 5th. The hat is 5, so we would have to combine it to something the exact same. Here we go. So I've got 3 plus 2. That's 5x to the 5th. Here I've got minus 7x, and this is minus 4x. Those are the same hats, so we can add those. Minus 11x. And we got plus 3 minus 11. That comes out to be minus 8. Okay, great. On this next one, things aren't written in order. Maybe you wrote them in order. That's fine. I'm going to just go ahead and look for hats. I've got x to the 4th. I don't see any other, so I'm just going to write that down. X to the 4th. Now let's look for x cubes. I don't see any other x cubes except that one, so let's go ahead and write that down, x cubed. Now let's do the squareds. 3x squared plus 5x squared comes out to be 8x squared. Cool. Now let's just do the x's. There's only just one x, so we're just going to write x. And then we do have some numbers. 1 plus 2 comes out to be plus 3. So again, if something doesn't match up, it's not a big deal. It just doesn't add to anything. And so we just write it. Last one here, combining like terms. We have an x squared plus an x squared. That's, again, there's an implied 1 here. So 1x squared plus 1x squared is 2x squareds. And then we add the numbers plus 8. Okay, that's how we do it. Let's take a look at subtraction. I quickly want to review one thing, and that is back in chapter 2, we talked about how whenever you have a number outside the parentheses that's being multiplied to the parentheses, you can take that number in as long as you multiply it to everything that's inside the parentheses. So this 2, for example, would go to that x squared, which would get us 2x squared. The 2 would also go to the 3, which gets us plus 6x, and this 2 would also go to this minus 5, which would get us negative 10. Please note that the same would apply whenever you just have a negative out front. This is an implied negative 1, so this negative would go inside and get us negative 2x squared. The negative would go inside here and get us minus x, and the negative would go inside here and get us plus 7. Just the signs just change. That's all that happens. Same here. We would get minus 3. The sign would change here. It would become plus x squared. And then the sign would change here as well, giving us plus 7x to the 4th. If we think of negatives this way, this will really help as we start subtraction. Because for all subtraction problems, when we do polynomials, it helps to distribute the negative. Let me show you an example. Okay, so let's say we're subtracting some polynomials. I would encourage you, every time you subtract polynomials, to turn this problem into an addition problem simply by distributing this negative through the parentheses. So if we did that, I'd have 5x cubed plus 2x squared minus 3x plus 7. And then as we distribute the negative in, we get minus 3x cubed minus 8x squared minus x plus 10. Now this entire problem has the negative distributed through it, and now we can combine like terms. So we've got 5x cubed minus 3x cubed. 5 minus 3 is 2x cubed. They're wearing the same hat, so we can combine them. Here we have 2x squared minus 8x squared, which would leave us with a negative 6x squared. Now let's do the x's. Here we have a minus 3x minus 1 more x. That's negative 4x. And lastly, plus 7 and plus 10, plus 17. And so this is the answer we get when subtracting these polynomials. Again, I'd highly recommend to distribute that subtraction sign. Distribute the subtraction sign and then combine like terms. Okay, great. Let's give you guys some problems to try. Okay, so here are your 3 problems. Go ahead and pause the video and give these subtraction problems a try, and then press the play button to check your answer. Okay, here we go. First thing I would do, and I would recommend everyone to do, is distribute that negative. It's just too not worth it. So I'm going to go ahead. We get 4x squared minus 2x plus 3. I'm going to take that negative, distribute it to here, so minus 7x squared. The negative to here, minus x, and the negative to here, which would make it plus 11. I then combine the like terms, x squareds with x squareds. 4 minus 7, that's negative 3x squared. Negative 2 minus x, that's negative 3x. And 3 plus 11 is 14. Okay, good. Again, distribute the negative here. X squared plus 9 minus x squared plus 9. So x squared minus x squared, those cancel out. 9 plus 9, you just get 18 on that one. Kind of interesting. Here we get x to the 4th plus 3x squared plus x. We distribute the negative, so negative x cubed minus x squared. The minus minus becomes plus 5x minus 1. Then we can combine our like terms. X to the 4th, there's nothing else. Nobody else is wearing a 4 hat, so we just write that. X cubed, here's an x cubed. No other x cubes though, so we'll just write that in, minus x cubed. X squared is 3x squared minus x squared. So 3 minus 1, that's 2x squared. Here we have a plus x and a plus 5x, that's plus 6x. and lastly a minus 1. So that is the answer for the third one, where we will be discussing multivariable polynomials. Now, it kind of sounds scary when you're talking about multivariables, but that just means that in a problem we're going to have maybe x's and y's rather than just one single variable. So this section 4.7 is not really unique because it's basically redoing all the sections we've done, the last 3 sections, just with multivariables, multi-letter questions rather than just a single variable or single letter. So let's take a look at an example here of a multivariable polynomial. Let's say I had x squared plus 3y squared plus 2xy plus 5. This is an example of a multivariable polynomial because it has x's and y's in it. And so for problems like these, we're basically going to be doing the same thing. We're going to learn how to add, subtract, multiply, and evaluate as well. So let's start with evaluation. Usually that's the easiest. So what if I said x was 3 and y was -2? So again, if I told you those informations, you'd go ahead and plug 3 and -2 in for, well, 3 goes in for x, so I'd have 3 squared plus 3 times -2 squared plus 2 times, let's see, x is 3 and y is -2 plus 5. Once you plug those values in, you just use order of operations. Use your PEMDAS to go ahead and evaluate these. First things we do is exponents. So 3 squared is 9 plus -2 squared. Ooh, don't get tricked up on that. -2 squared is 4, so 3 times 4 plus 2 times 3 times -2 plus 5. Okay, so we did exponents. Now we would multiply. And so I'm left with 9 plus 12 plus, actually that's going to come out to be minus because it's going to be 2 times 3, which is 6, times a -2, which is -12 plus 5. And our last step is to add. Notice that 12s cancel out. So really all we have is 9 plus 5, which is 14. So that's how you evaluate a multivariable polynomial. Just make sure that you get the right x in for x's and the right y's in for y's, and then use order of operations to evaluate. Let's have you guys try one. Okay, so here are 2 problems for you. The first is a multivariable polynomial question where x is going to equal -3 and y is going to equal 2. And on number 2, I've gone ahead and given you the surface area equation. Surface area equals 2 pi times the radius times the height plus 2 pi times the radius squared. So I've gone ahead and given you the radius of 2 inches and the height of 5 inches. That's a pop can. And so we'll see what you guys come out with for the surface area, how much aluminum has to be made for an aluminum pop can. Go ahead and pause the video and plug those values in. Let's make sure you get the same answer, and go ahead and push play when you're ready to check. Okay, so we're evaluating multivariable polynomials. In other words, we're just plugging values in. We're going to plug in -3 here for x squared, for x, and 2 in for y. So I get 2 times -3 squared. Ooh, that's a pretty blue. Plus 5 times 2 cubed minus 3 times -3 times 2. There's never enough room here. Plus 2 minus 2. So I went ahead and plugged in -3 for all the x's and 2 in for all the y's. That was my first step. Okay, now we use order of operations to finish this problem up. -3 squared, that's -3 times -3. That comes out to be a positive 9. So 2 times 9 plus, 2 cubed. 2 times 2 times 2 is 8. So 5 times 8 minus 3 times -3 times 2 plus 2 minus 2. So I went ahead and did exponents. Now the next step in order of operations is to multiply. So we get 18 plus 40. Ooh, this is going to become plus 18 because it's a -3 times -3. That's plus 9 times 2 is plus 18. Plus 2 minus 2. And so we can bust out a calculator here and finish up the problem. The 2's cancel out, and our final answer is 76. How'd you do? Hopefully you did all right. This is just evaluating, doing some order of operations, nothing big. So on this one, we're going to plug 2 in for the r's. So a 2 goes in there, a 2 goes in here, and then a 5 in for the h. And so we get 2 pi times 2 times 5 plus 2 pi times r squared. Then that's just 2 squared, which is 4. And so our final answer here is 20 pi plus 8 pi, and 20 pi plus 8 pi, put them together, and what do you got? 28 pi. Okay, good. So that is the first part of this lesson, just making sure we can evaluate multivariable questions, polynomials. The next part of the lesson is just adding and subtracting, and that when we add and subtract polynomials, all you do is combine like terms. Now, remember, combine like terms. Like terms have to be exactly the same. They got to be wearing the same hat. They've got to have the same variables. If not, they are not like terms. So be aware of that. Don't get tricked here. So for example, the first one we have here, if we're going to start adding these two polynomials, everything's got to be the same. So here I have an x squared. Is there anywhere else that I have an x squared? Well, here's a y squared. But we can't combine those. Those are not the same. So we've got 3x squared. I'm looking for any other x squareds. No, no, no. X squared. Bing! So those can be combined. If I have 3x squareds and 2x squareds, well, that comes out to be 5x squareds. Okay, good. Let's take a look at the next one here. Here we have y squareds, and we're looking for any other places with y squareds. Nope. Nope. No, no. Y cubed? No, those are not the same. They're wearing different hats. They cannot be combined. Y squared, no. So there's no other y squared. So we're just going to write down 2y squared. There's nothing else to combine it with. They have to be exactly the same, like terms. Here we have xy as our term. So xy, any other xy's? No, no, no. Oh, here's an xy. So these can be combined. 3xy plus 2xy comes out to be 5xy. Okay, here I have the number 5. Any other number 5s? No, so I'm just going to throw that in. Here we have y cubed. There were no other y cubes to add, so we'll just throw in y cubed. And here we have an x, but there's no other x's to add together. There's nothing like terms with it, so we just write it in. And so this would be our answer. Sometimes we want to write these in descending order, so maybe the y cubed would come first. Then 5x squared plus 2y squared plus 5xy plus x plus 5. This is probably a nicer way to write this. Again, it means the same thing. We just like to write it in descending order. When there are multivariables like x's and y's, some of you may have asked, well, why did you put the x squared first and not the y squared? It really doesn't matter, but rule of thumb usually states that you should do this in alphabetical order. So since they were both squared, I went ahead and put the x's first. Again, that's not super critical, but that's a good rule of thumb if you want to follow. So that would be our final answer. Again, just adding like terms. If they are alike, you add them. If not, just write them in your answer. Okay, so here are 2 questions for you to try. Again, you're just adding, in this number 1, you're going to add the polynomials together. And number 2, you're going to subtract the polynomials. So go ahead and combine. Again, we just combine like terms on these. Go ahead and pause your video and check your answer by pushing the play button. Okay, how'd you do? Let's find out. Again, this is just like our previous section, so we're not going to do as many practice problems because it's pretty much kind of redundant. We're just combining like terms here. So I've got x squared. Are there any other x squareds? No, no. Oh, here's an x squared. Sweet. So 2x squared, 3x squared comes out to be 5x squared. Now I'm looking for some xy's. Any other xy's? No, no. Ah, here's some xy's. So I have negative 1xy minus 7 more xy's. So negative 1 minus 7, that comes about to be negative 8xy's. Okay, sweet. Now y squareds. Combine my y squareds. Y squareds. Ah, here's a y squared. So we have plus 1y squared minus 1y squared. Ooh, those cancel out. And so this is my final answer. 5x squared minus 8xy. We just combine the like terms. On this next one, It may help. Remember, when we subtract polynomials, we said that it's really good to distribute the negative. So I think I'm going to go ahead and do that. I'm going to switch this minus to a plus and distribute that negative into each of the terms. So this becomes minus 2ab. This becomes minus 3a squared b. And this becomes minus 5a cubed. It's really nice to make subtraction problems, addition problems, simply by distributing the negative. Okay, let's see how we get what like terms we have. We have a cubed. Any other a cubes? That's a b cubed. No, 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 no. Oh, here's an a cubed. So we have a cubed minus 5a cubed. That's going to get us a negative 4a cubed. My next one here is b cubed. Let's look. B cubed. No, no, no. I don't have any other b cubes, so I'm just going to go ahead and write that in, minus b cubed. Here we have ab squared. I'm looking for ab squareds. Here's an ab squared. Ooh, this is an a squared b. Ooh. Now, be careful. Those are not like terms. They're not identical. They got to wear the same hats for you to be able to combine like terms. So I'm only combining these here because they're ab squareds. I had 3 minus 2. That's plus 1 ab squared. Now the last thing I need to take care of is these a squared b's. There's no other like terms for those, so I just write in minus 3a squared b. Good. On that problem, the only tricky part is to remember that these are not like terms. ab squared is not a like term with a squared b, so you write them separately. Okay, great.